Okay. Today we shall be developing. Today we shall be developing developing EGARCH model. So that is our plan. We shall be developing EGARCH model. So in other words, our topic is leverage in the EGARCH model. So that is our topics. That means our topic is the leverage in the EGARCH model. So meaning that this one actually is the leverage model that we shall be developing today. Okay, leverage model that we shall be developing today. And here we have the data BSR, right? The BSR, here is the data. What is BSR? That is Bangladesh stock return. That is called BSR. And the sample size for this one is how much? How many? 200. You can see the sample size 200, and the variable is BSR. That is Bangladesh stock return. And also we have another variable, that is C. What is C? C means constant, or that is constant of the model. Okay, now the question is should we run EGARCH model or EGARCH model, right? That is the question. Now the question is, should we run EGARCH model or EGARCH model? And here EGARCH actually is the family member of EGARCH model. Here EGARCH actually is the family of the EGARCH model. Okay, now the thing is, when we should run EGARCH model, there should be a guideline to run EGARCH model. Okay, so what is the guideline? Okay, what is the guideline? Okay, the guideline number 1. The guideline number 1. What is the guideline number 1? First we run the regression model such as BSR is the dependent variable and C. What is C? Constant. And here there is no other independent variable, only these two, BSR and C. Okay. So what we do, so I go to quick estimate equation, and here I put BSR and C, right? BSR and C, and here BSR is the dependent variable. What is BSR? Bangladesh stock return, and C is the constant, and here is no independent variable. So here I can run the model. So I click on the OK. So this is my model that has been estimated. Okay, that has been estimated, my model. And from this model, so this is the dependent variable BSR. Okay, now from this model I check the residual. So here you can see residual of this model. I click on the residual. Okay, and you can see that is the residuals, right? And here actually the data from day 1, it is the day 1 until day 200. So actually we have our sample size is 200 days return. Actually our sample size is the 200 days return that I am writing here. Our sample is 200 days return of Bangladesh stock, right? Return, right? 200 days. That is BSR, right? 200 days of Bangladesh stock return. What is stock here? Stock means equity. Here stock means equity return. Stock means equity, right? Equity return. Stock means here equity return. Okay, this is important. Stock means equity return. 200 days. So it is the day 1, this point, and this point is the day 2. And all these things are what? These are the residuals, right? These are the residuals. Okay. So now from day 1 until day 40, around day 40, so here the fluctuation is very small, right? That means volatility of the residual is very small, right? Meaning that period of low volatility is followed by another period of low volatility for a prolonged period, meaning that 40 days continuously. Okay, here actually I can write the story that from day 1, right, day 1 to day 40, you can say, such as day 1 to day 40, about day 40, we can see that period of low volatility is followed by period of low volatility for prolonged period. Okay, Again, you can see from here, suppose from here, day 40 until you can say day 75, right? From day 40 until day 75, from day 40 until day 75, what is happening here? Here is period of high volatility is followed by period of high volatility. So that means one high volatility has been caused by another high volatility for a prolonged period. Okay, again you see from here 75 day, from 75 day until 150 day, right? From 75 day until 150 day, right? Here the period of small volatility is followed by another period of low volatility for a prolonged period, right? And again you can see from 150, from here 150 to 200, right? From here to here 150 to 200, the period of high volatility has been followed by period of high volatility. So actually what we have seen, from day 1 until here, period of low volatility is followed by period of low volatility, and again from here until here, period of high volatility is followed by period of another high volatility. Again from here to here, right? From here to here, the period of low volatility has been followed by another period of low volatility. So here the period of low volatility has been followed by another period of low volatility, and from here to here, right, you can see period of high volatility has been followed by another period of high volatility for a prolonged period. So when this thing happen, we have the justification to use EGARCH model. When this thing happen, in residual distribution, then we have the justification to run EGARCH model or EGARCH model. Okay, this whole thing we can check in other way. This thing we can check using arch test whether we should run EGARCH model or not. Okay, so we can do the arch test now. So where is the arch test? I go to view, residual diagnostic, then you can see heteroscedasticity test, right? I click here, and from here you can see arch, right? You choose the arch, then click OK. So this is the arch test and the result, and here is the observed R square and a corresponding p-value. How much is the p-value? The p-value is this one. P-value is here 0.0019, meaning that 0.19%, right? Okay, that is the p-value. And what is the null hypothesis? The null hypothesis of null hypothesis is there is no arch effect, right? And what is alternative? Alternative hypothesis is there is arch effect. Okay, and here you can see our p-value is very small, less than 5%. So we can easily reject null hypothesis and can accept alternative hypothesis, meaning that there is a arch effect. So our model has a arch effect. So we can easily run arch model. We can easily run arch model, and that we shall be doing now. Okay, so actually there are two conditions. Number one condition actually this one that I said previously. Number one condition that when the when the period of low volatility is followed by period of low volatility, and when the period of high volatility is followed by the period of high volatility, then we should run the arch model. So that is number one, and that we have got it already. And the second condition is, second one is, if there is a arch effect in the residual, then we should run the arch model. And here we have seen that we have arch effect, so we should run arch model. And EGARCH model, actually EGARCH model is a family of arch model. Okay, so now we can run the EGARCH model. Okay, the question is that how to run the EGARCH model. How to run? I go to option, right? Sorry, I go to quick. Okay, and also I can do from here. Here I can click estimate. I can see estimate. I click here, estimate, Then I can put BSR, our dependent variable, and constant, right, C. And method, I choose suppose arch, right, arch method. So, and here there is no other independent variable, right? So only BSR and C. There is no other independent variable, only BSR and C. But if you want, yeah, we can add more independent variable, but we do not want to do here. We have no plan. And from here, I choose the EGARCH, right? I choose the EGARCH. And here is what is happening here. In this EGARCH model, there is a arch1 and GARCH1, and the order is 1. And from this model, so the whole thing, this one is called mean equation, and this one is called variance equation. So meaning that it has two parts. One is mean equation and one is variance equation. And what is happening, actually the residual from the mean equation has been used in the variance equation. So that is the thing happening here. I am saying here the residual derived from mean equation has been used in the variance equation to estimate the variance equation. That means I am saying again, that is okay. And here suppose there is no variance things, right? There is no variance variable. So I keep it blank. And here I choose suppose normal distribution. Then what happens? Because here are so many distribution, normal, student, right? But I choose only normal distribution to check. Okay, everything is set now, right? Everything is set. Then I proceed with this model. I click OK. So this is my result, right? This is my outcome. This is the EGARCH model.